Welcome back. We're going to work our way into video 5 as we continue our study of Unit 5. So with no further ado, let me get you to a share here. We're moving into section 4.3. There we go. Oh, come on now. There we go. All right. Section 4.3 on the horizon. We're going to do greatest common divisor, GC, and least common multiple, LCM and GCF, greatest common divisor, your book likes. I grew up calling that greatest common factor. So as it's true, old habits tend to die hard. Okay, so we'll see several methods to do this. We'll use prime factorizations. That's probably the way you might remember. I like the Venn diagram approach, and years ago I ran into this ladder method. I really kind of like it, so I'm going to show you those as well as methods that we can use to find least common multiple and greatest common divisor. Okay, so it can be your call. If you want to call it greatest common factor, I tend to go back to what I'm used to, and that's greatest common factor, greatest common divisor. Okay, greatest common factor. Two numbers, A and B, is the greatest whole number that divides into both A and B. So you're finding the biggest factor that you can that the two values have in common, greatest common factor. Least common multiple for two numbers, A and B, is the least non-zero whole number that is a multiple of A and a multiple of B. When you ask kids to do this, they tend to build lists, and that's not a horrible approach. They'll just build the list and they'll find the biggest common factor that they can, and they'll find the least common multiply. And that's fine. I don't know that we want to deter that. I tend to think as kids get older, you want to show them more, I don't know, systematic approaches, and that's what these are. So we'll take a look at the Venn diagram approach. I think you'll like that. So first of all, we need some prime factorization. So we'll bust out the old factor trees again, and we'll do that. And then at the end, I'm going to show you this ladder method. I think you'll enjoy it. Your book does talk about the Euclidean algorithm. I think it would be too bizarre for elementary kids, so I'm not going to get bogged down in that. So I would encourage you. The Venn diagram approach is a good visual. I think you're going to like the ladder method. I think you can, hang on to one of those two as a go-to method. All right, prime factors to determine GCFs and LCMs. First of all, we got to go ahead and find the prime factors. The greatest common factor is found by using the minimum exponent for each shared prime power. So that's kind of counterintuitive. You hear greatest in GCF, but then you take the smallest exponent, and that's only in the primes that are shared in that prime factorizations. Least common multiples is found by taking the maximum, the biggest exponent on any prime, whether it's shared, common, or not. So I thought what we'd do is we would find both GCFs and LCMs for 120 and 200. So first of all, we got to bust out some primes. So I went ahead and did the whole thing. I broke down. Now, this one I did a little differently. I did 12 times 10 as my first break on 120, and neither of those was prime. So I continued breaking down, and you'll see that 6 is a factor on the 12, was not prime, so I didn't circle it. So again, I'll stay with my convention. I'll circle the ones that are primes. So I got a bunch of 2s, and I got a 3 and a 5, and it looks like the prime factors for 120 might be about 2 to the third times 3 times 5. Cool. How about some prime factors for 200? Sure, don't mind if I do. Looks like a bunch of 2s, looks like 2 to the third, and maybe 5 to the second. Okay, so if we're going to make use of those to create our GCF and LCM, here's what we will do. This is just a recap. Okay, so those are your prime factors that we just found with our factor trees. 120 at 2 to the third times 3 times 5. 300 is 2 to the third times 5 squared. To find greatest common factor, what we are asked to do is take the smallest exponent on the primes that are common. All right, so first of all, both of those have 2s as a prime factor, and they both have 5s. They do not both have 3s. 300 does not have a factor of 3. All right, so we're finding our greatest common factor. It'll be 2 to the third times 5 to the first. Right, there's my common factor at 2. There's my common factor at 5. So my greatest common factor, 40. The LCM is found by taking the maximum exponent on any prime. So in that case, we'll take the 2 to the third, we'll take the 5 to the second, we'll take the 3 to the first, we'll multiply all those together, and we'll find our least common multiple to be 600. That's cool. All right. I like the Venn diagram approach. I think I prefer to what you just did. I think it's too hard for some kids to hold the notion of do I use only the ones that are common, or do I use them all, and why do I pick the biggest one, and why do I pick the smallest one? This is a good visual approach, and I think it's going to make a lot more sense to the kids that we teach. So again, what we'll do is we'll bust out some prime factors. So we'll look for primes on 24. We'll look for primes on 60. So there you go. It looks like 2 to the third times 3. 60 looks like 2 squared, 3 and 5. Okay. Now, what we're going to do is we're going to fill in a Venn diagram. So there are your factor primes. Okay, 24 is 3 2s and a 3. 60 has 2 2s, a 3 and a 5. Okay, so on the left side circle, I'm showing you factors of 24, right? They were 2, 2, 2, and 3. On the right side circle, I'm showing you prime factors for 60. They were 2, 2, 3, and 5. So you'll notice in the intersection of those two circles, I'm showing you what's common. There are 2 common primes, 2, and there's a common prime of 3. And then in the remainder, or if you think about the outside of part of the circles, I have listed all of the primes that weren't common to both. So 24 has a factor of 2 kind of hanging out there, and 60 has a factor of 5 kind of hanging out there. And say, all right, I could do that. I can identify the ones that are common and put them in the intersection, and I'll put the others that aren't common in the outside parts of the circle. And here's how it works. The greatest common factor you create, if you will, by multiplying the numbers that are inside on that intersections. So it's going to be 2 times 2 times 3, and that means 12. So the greatest common factor for 24 and 60 would in fact be 12. If you want to calculate the least common multiple, what we will do is we will multiply all of the numbers together inside the Venn diagram. So a 2, a 2, a 2, a 3, and a 5, and that's 120. So our least common multiple of 24 and 60 would in fact be 120. Okay, second example with Venn diagrams. Let's go ahead and get our primes. So for 200, looks like a bunch of 2s, a couple of 5s, 2 to the third, 5 squared. For 60, looks like a couple of 2s, a 3 and a 5. There's a recap for you. All right, so I'm just reminding everybody what the factors were for those numbers. And again, what we're going to do is we're going to put anything that's common to those 2 primes on the inside, the intersections of those circles. So that was 2 2s and a 5 that they had in common. 60 has also a factor of 3 that wasn't common. And 200 has 2 additional factors, 2 and 5, that were not common. So you say, well, let's do it. Yeah, that's the greatest common factor. Will be the product of 2 and 2 and 5. That'd be 20. And the least common multiple is the multiplication aspect of all of those numbers. So 2 times 2 times 2 times 3 times 5 times 5, 600. And that, my friends, will shut down video 5 for Unit 5. We'll be back soon with our last video from Unit 5. See you then.